Hello, class. We are starting section 5 chapter 5. In the first section, 5.1 is talking about trigonometric ratios and right triangles. We're going to head back to those geometry days where you learned all about the SOHCAHTOA and the relationships between angles and their sides. Okay, so you can follow along on page 294 in your textbook. So the first thing that I want you to do is just to get reacquainted with a right triangle. And so go ahead and draw a right triangle here on your page. So if we do that and we draw the triangle, sorry about that, guys, that is on that page, you can see that the side length is opposite of the corresponding angle. So you always need to have that 90-degree angle, and you need to make sure that you put that it is a 90-degree angle. So include that 90-degree box to let that be known. Now, opposite angle A is side A, and that is a leg. The leg opposite of angle A is side A. C is your hypotenuse. It's opposite angle C. And B is the leg opposite angle B. So sine of theta, of any given theta, any angle that we are given, is the leg opposite of that angle divided by the hypotenuse. And cosine is the leg adjacent to that angle divided by the hypotenuse. And tangent would be the leg opposite of the angle divided by the leg adjacent to the angle. And I'm sorry there's not any spaces in here, but I was unable to do that using the equation writer online. So looking at the first guided example on page 295, in triangle ABC, angle C is a right angle. The leg opposite to A has length of 20, and the hypotenuse has length of 29. Calculate sine A, cosine A, and tangent A. Your first step needs to be to draw the picture, so go ahead and do that. Okay, so I've drawn the picture, and I have triangle ABC, and all of my lengths are now filled in. And I wrote that sine of A is equal to the opposite divided by the hypotenuse, and cosine of A is the leg adjacent to A divided by the hypotenuse, and tangent of A is the leg opposite of A divided by the leg adjacent to A. And so let's go ahead and fill in these numbers. If this is our angle A, the leg opposite of A is 20, and we're going to divide that by our hypotenuse, which is 29. So sine of A is 20 divided by 29. Now cosine of A is the leg adjacent to A, which is 21 divided by the hypotenuse of 29. So the cosine of A is 21/29. And tangent of A is the leg opposite of A, which is 20, divided by the leg adjacent to A, which is 21. So tangent of A is 20/21. Go ahead and draw, or look at this next problem. In triangle DEF, angle D is the right angle. If DF equals 40 and EF equals 41, find sine of E, cosine of E, and tangent of E. Okay, so I have drawn my picture. It's not beautiful. I'm having a hard time with this calibration, but triangle DEF, angle D is my right angle, so I have my box there. I'm told that DF is 40, so I have a 40 between D and F, and that EF is 41, so I have my 41 here between EF. But what I don't know is what ED is. And so I need to use that Pythagorean theorem that says that I have a leg, ED squared, plus my DF squared, or 40 squared, will equal 41. So it's that A squared plus B squared equals C squared, but we're going to, we need to solve for this unknown leg. So go ahead and do that. That needs to be your first step. So I have F squared, which is the side opposite of angle F, plus 40 squared is equal to 41 squared. And so I need to use the Pythagorean theorem to solve that. So 41 squared is 1,681. So I have F squared plus 1,600 squared equals 1,681. So F squared would equal 81. So F equals the square root of 81, or 9. So side ED equals 9. So now I need to know what the sine of E is. And sine of E is the leg opposite of E, which is 40, divided by my hypotenuse of 41. So sine of E would be 40 over 41. Cosine of E is the leg adjacent to E, which is 9, divided by my hypotenuse of 41. And tangent of E is the leg opposite, which is 40, divided by the adjacent leg of 9. So I would have 40 over 9. Sonar on a salvage boat locates an object at a downward angle of 50 degrees and at a distance of 510 meters, as shown in the drawing. How far below the level of the water is the object? So your first step is to draw the picture, and you can find that on page 295. So if I draw this picture, I've got this angle here is 50 degrees. I know that this distance is 510 meters, and I'm looking for the depth. Okay, so if I'm looking for the depth, and I'm given the sine of an angle and a hypotenuse, because we know that this here is our 90-degree angle, I have to see what am I given. And right now I'm given the hypotenuse, I'm given my angle, and I'm looking for the opposite side. That's what I'm looking for. But I'm given the hypotenuse and the angle. So with that, I can use sine. I know sine is opposite over hypotenuse. So sine of 50 degrees is equal to the opposite side over the hypotenuse. Well, I'm given the hypotenuse, so I can say sine of 50 degrees is equal to the opposite, which is the depth that I'm looking for, divided by the hypotenuse of 510 meters, and I can solve for my depth. And I can do that by saying sine of 50 degrees times 510 meters is equal to the depth. And you're going to need to use your little calculators to figure this out. But what's really important is that you have your calculator in degree mode. You need to have it in degree mode. And if you do that, you will have sine of 50 degrees is about 0.766 times 510 is 390. So your answer should be about 391 meters, because we're asked to round to the nearest meter. Why don't you try this next problem on your own? So go ahead and pause the video and then check back and see if you got the same answer I got. So you go ahead and pause it, work the problem out, and then check your answer. Okay, so I am given that I have a 60-meter long string of kite, which would be my hypotenuse, and that it's because it's being pulled taut, that would be my hypotenuse. And I'm told that that the angle is 68 degrees. And I'm asked how far would the person be if they were directly underneath the kite. So my kite is up here, and so I'm looking for this distance here. So I'm given the hypotenuse, and I'm given my angle, and what I'm looking for is my adjacent side. And since I know that cosine of an angle is equal to the adjacent side of the angle divided by the hypotenuse, I can use some basic algebra and figure out that cosine of 68 degrees is equal to the adjacent side divided by the hypotenuse of 60. So I would multiply 60 by the cosine of 68 degrees and get that it is 22.48 meters from the original person. So how far would a person be if that person were directly underneath the kite? And the answer is 22.48 meters. So angle of depression and angle of elevation. What do they mean? Well, angle of depression is when you're looking out that it's decreasing. So the angle of depression to an object is the angle formed by the horizontal ray and the ray with the same endpoint that contains the object if the object is below the horizontal. And the angle of elevation would be, and this is directly read from your book, the angle of elevation is if the object is above the horizontal ray. So it would be going this way. So it would be, one is when it's below, depression is below the horizontal, and elevation is above the horizontal.